Hey guys, are you ready to dumb down math with me? Let's go. Here is a question from simple equation. There is a magic box with a magician. If you put anything in it, close it and then open, whatever you had put in it will get doubled. The magician put a certain amount of money in it, closed the box and then opened. After that, he gave an amount X from the box to someone and then closed the box. Again, he opened the box and gave the same amount X to someone else. He did it 12 times and after that he had rupees 4095 in the box. What was the least possible initial amount he had put in the box? The question, as you can see, is pretty long, but I'll make the solution as short and as simple as possible. So you may pause the video for a short while, take a close look at it and get familiar with the different facts and figures given in the problem. We don't know how much money the magician had put initially in the box. In fact, that's what's to be found out in the problem. So if you don't know something, what do? You take it as some variable. Let it be A. So A is the amount he had put in the box initially. And then what does he do? He closes it and again opens it. This A will become 2A when he opens it again. See, whatever you put, for example, if you had put 100 rupees, it becomes 200 rupees. If you had put A amount of money, it becomes 2A. Then what does he do? He takes a certain amount which is specified as X, variable X in the problem. He takes so much money from the box. That means so much money has to be deducted from that. This is what remains in the box after giving X amount to someone in the audience. This is the first opening. Now what does he do? He closes the box again with how much money? 2A minus X, whatever you had here. Again he opens the box and this will get doubled. Doubled means 2 into 2A minus X. And after that what does he do? He takes the same amount. That amount being given to somebody else is a constant which is fixed to be X. And that's taken from here. So you minus that. Then you simplify it further. 4A minus 2X minus X, which is 4A minus 3X. So this is what you will see in the box after the second opening. Now he is again closing it with how much money? This much. 4A minus 3X. Let me draw a line here. Don't confuse these two. Here I am writing whatever amount that was there in the closed box. Again, opening is done here. It gets doubled. I am skipping one step. You double this. It will be 8A minus 6X. As soon as he opens the box, this is what he sees. Again, like in the previous case, X amount being shared with someone else. Now you simplify this, you will get 8A minus 7X. This is the third opening. Now he does it how many times? 12 times. But if you look at the amount that is there in the box before closing, you can see a pattern forming. Look at this. Third time, 8. 8 you can write as 2 power 3. And 7 is 1 minus, 1 less than 8. So you write 2 power 3 for 8 minus 1. Sorry, I missed A here. This is X. If you want, this also you can write as 2 power 2 A 2 power 2 minus 1 X. So there is a pattern forming. He does it 12 times. So let me work out like this how much money was there in the box after he opens it 12th time and sharing X amount with him. That will be You go on like this. You don't have to write whatever you see before that. Straight go to the 12th time. There is a pattern forming. You use that. After he does the whole thing, in the 12th time, you will see 2 power 12 a minus 2 power 12 minus 1 x. This is what is going to be there in the box after he does the 12th operation completely. And this amount is given in the data. You may refer back to the data. This is given to be how much? They say the box had 4,095 rupees. Now, let us simplify this. See, can anyone guess 2 power 12? It's a good to know the powers of 2 at least up to 12, because you keep coming across these numbers in many competitive exams. So it will be in your own interest to learn by heart powers of 2 up to 12. Anyway, I'm writing what that is. 2 power 12 is 4096a. This is this amount minus 1. Obviously, that will be 5x equal to 4095. Now, you take this to the right side because you are looking at A, the amount he had put initially. So that will be 4096A equal to, write whatever is there already on the right side, and this you are taking to the right side. Minus becomes plus 4095x. Okay. Now let me write that again. 4096A. Right side you see 4095 being repeated twice. So you take it out. 4095. Inside what do you get? 1 plus x. Okay. Now this implies what? You are finding A finally. You keep A here. First write whatever there on the right side. 1 plus x. Bring this to the right side. 4096. Now you got A as so much. Now look at this. Both A and x are positive integers because they denote what? The amount you're putting in it. So it cannot be a fraction. It cannot be negative. So A and x are restricted to be positive integers. Now there is only one equation we have. One equation with the two unknowns. So obviously you will get infinitely many values for both these variables. But there are some other restrictions in the problem using which we will try to get a unique value from those infinitely many values. So before that, this is an integer. So the whole thing, this must be also a positive integer. For this fraction to be a positive integer, there is no common factor here. So 1 plus x, you don't know what it is. If 1 plus x is a multiple of whatever you see in the denominator, then the whole thing will get simplified to an integer. Basically, what I mean is 1 plus x is a multiple of 4096. For any other values you substitute here, this will get simplified as again another fraction. But if you restrict 1 plus x to be a multiple of this, the whole thing will get simplified as an integer, which it should be because the left side is an integer. Now let's substitute that here. 40. Okay. What do you mean by this is a multiple of 4096? It means if this is a multiple of this thing, 1 plus x equal to 4096k, where k is 1, 2, 3, etc. That's the meaning of one number being a multiple of other. Now 1 plus x is in this form. You substitute that here into 4096 into k divided by 4096. Now look at this. These two will cancel out. you have 4095 into k. What does that mean? A is equal to 4095 k, where k is ranging from 1, 2, 3, etc. A equal to 4095 into k. This indicates A has infinitely many values, as you put k as 1, 2, 3, etc. But look at the question. We are not asked to find out just the amount the magician had put in the box. The question says specifically what is the least amount he had put in the box initially. How do you find out the least of all this? See, theoretically speaking, this means 4095 into 1, 4095 into 2. It goes on like that. Obviously, this is the least amount. For all other values substitute in place of k, you get bigger ones. So A is equal to 4095. So this is the amount, rather this is the least amount the magician had put initially in the box. If there is any point you're still unable to follow, please raise it in the comment section. I'll be happy to address it there. See you in the next video. Bye.